Agilent was proud to be a co-sponsor of the first CPSA Shanghai meeting. And so brief little Mike Lee story. If he's one memorable dinner we had in China. Mike leans over to me and says, "Tim, is the food supposed to move?" And I said, "Don't worry, it's China." So anyway, that was interesting. A little bit about ion funnel. So at Agilent, we have competition internally with our GC-MS group. They get a lot of ions into the GC mass spectrometer, 1, 2, 3, 4%. We do much worse in LC. We do terrible in LC-MS. So we've been always trying to improve this. Our source design, our Agilent Jetstream, trying to confine the ions, concentrate them in front of the mass spectrometer, all kinds of tricks. Let's open up more holes. Hexabor capillary. This is the first, I believe, multi-capillary implementation. And then a dual ion funnel borrowing on the work from P&L Labs. One feature of this dual ion funnel is that it's offset. So if you look at line of sight, the ions have to actually move up and then come down, and this removes neutrals and noise. Does a pretty good job of that. Also, the speeds coming through here are really very, very fast. So ions are moving faster than 100 miles an hour. You know, like jet speed coming into here, and they slow down. They slow down some more, and they get into the mass spectrometer. All right, ion funnels. Old, new. Old ion funnels made out of metal, stacks of metal plates. Looks like a radio transformer. If anyone was a ham radio operator in the day, that's what these things look like. What's the problem? They're hard to clean. Active surfaces take a lot of power. Modern implementation, printed circuit boards. Yeah, maybe we can replace quadrupoles with printed circuit boards. These printed circuit boards have conductive gold rims, very, very small amount of surface, very inert, robust, handle lots of gas, and keep the ions in. What does that do for you? You can get detection limits below 100,000 in solution, 100,000 molecules. So this is 100 zeptomoles. You're getting the zeptomole land. That's pretty impressive. Not single molecule detection yet, but this is almost single cell detection kind of things. If you look at the number of molecules on a cell surface, yeah, about 100,000, 50 to 100,000. So this is beginning to get in that range of sensitivity. However, this is in solution. This is not in plasma. Okay, how do we do in plasma? So for crash plasma, protein precipitated plasma with ACN, we're not into zeptomoles. We got low attomoles or 2,000 zeptomoles. So this compound, fluticasone propionate, inhaled drug, may be better known as Flonase. People out there taking Flonase. Not bad. So maybe 20 times less sensitive in plasma, but still pretty darn good and a lot better than we were before. What about robustness and reliability of these funnels? Solid as a rock, over 2,000 plus plasma injections. Okay. They will eventually get contaminated. All sources, all optics eventually get dirty. So what do? You plug it out, comes in a stack, you stick it in isopropanol, you sonicate for 15 minutes. Now, admittedly, because you have to vent and repump, it takes a little bit longer. But basically, very, very simple operation. We want to thank our collaborators, Dick Smith, we worked very, very hard with, and his group, and especially Keki Tang, in developing this ion funnel technology. Dick's published, obviously, for a long period of time in this area, and we want to acknowledge all his contributions. We are still working, we have a very close relationship, ongoing relationship with P&L. And our first implementation of ion funnel technology is on our new 6490 triple quad. Thank you very much.